Hello, my name is Dan Oak and I'm a student at Athabasca University, currently taking the course Computer Science 444, Embedded/Robotic Programming. And if you've been following the videos that I've been posting to the course forums so far, you'll know that I'm going through the SparkFun Inventor's Kit Guide and I'm showing you how I've completed some of the projects along with the associated coding challenges. So I've already got videos posted to the course forum showing me completing projects 1, 2, and 3 along with the associated coding challenges with those projects. And in today's video we're going to be going through Circuit 4A of Project 4. So what exactly are we going to be going through in today's video? Well, we're going to be going through, again, Circuit 4A of Project 4 from the SparkFun Inventor's Kit Guide, but our main focus is going to be on the coding challenge more than the regular circuit. In the coding challenge I'm going to utilize the LCD to display Hello World, track the time elapsed since the Arduino was last reset, count button presses from multiple buttons, and read the value of a potentiometer. The project employs the liquid crystal library to control the LCD, connecting it to specific Arduino pins for data and control. And then during the setup, we will initialize the LCD display dimensions and clear any previous content. In the loop, the code continuously updates the LCD with real-time information, such as the elapsed time derived from the millis function, along with displaying the count of button presses and the potentiometer value, based on the user input through the serial monitor. So I'm using the serial monitor to allow the user to decide what to display on the LCD screen, basically. The challenge also involves implementing a menu system that allows the user to switch between displaying a custom message, besides Hello World, the elapsed time, counting button presses, and showing potentiometer values while still updating the LCD live without disruption. A significant focus of my challenges during this coding challenge, which it was a challenge, was on the complexities of using the serial monitor for input and managing state changes in the menu selections to ensure responsiveness. Troubleshooting common issues such as ensuring accurate button counting while allowing for smooth transitions between different display modes will be discussed in this video, revealing the intricacies of maintaining real-time feedback in an interactive setup. As well as always, this project encourages experimentation with LCD displays and user input, providing insights into building more complex interactive systems. So again, as always, I encourage you guys out there, especially you Comp 444 students, to make your own circuits, do the coding challenges in your own creative ways, and just really play around with these things. They're a lot of fun. So without further ado, let's get straight to the SparkFun Inventor's Kit Guide. So we're going to go to Project 4, and again, if you followed the videos that I've been posting to the course forum so far, you'll know that I don't read the guide in its entirety, considering it's available to all Comp 444 students, or really anyone who goes to the SparkFun Inventors Kit website and just looks for the PDF download of the guide. So I'm really just going to cover highlights. But again, if you either go to the website, download the digital guide, or use the paper copy you got when you registered for the Comp 444 course, you can follow this in more detail. So Project 4, the main focus is on liquid crystal displays, LCDs, which allow you to print things like sensor data and strings of words to the display. So the new concepts that are going to be introduced in this project are the liquid crystal display, as well as the digital temperature sensor. We're not going to be getting to that in this video. That is in projects 4B and 4C. We're also going to introduce a lot of new concepts in Project 4, but the one that's going to come into play really today is the button debalance. So, Circuit 4A. Just increase this a little bit. Circuit 4A, LCD Hello World, is, well, kind of what you would typically do at the start of any program. So Hello World is usually the first thing that programming tutorials in a new language will have you do, printing Hello World to the console. In the Arduino world, it's a little different because the Arduino is really focused on hardware and interacting with the real world through hardware, like LEDs, actuators, and that sort of thing, motors and sensors and different things. So this guide actually starts in Project 1 by blinking an LED, because that's typically what you do. That's the Hello World of the Arduino world. But today we're actually going to go back to the kind of original Hello World in most programming languages by just outputting some real text, in this case to an LCD and not to a console. So as you can see, you're going to need your LCD display that came with your kit, a potentiometer, and some jumper wires. So, new concepts discussed today. We're going to talk about character liquid crystal displays. Okay, and essentially what they are, they just show letters, numbers, or any other special characters on an LCD screen. So when current is applied to this special kind of crystal, it turns opaque. So this type of technology, these LCD screens, are used a lot in calculators, watches, and just simple displays. Adding an LCD to your project will make it portable and allow you to integrate up to 32 characters, 16 by 2, bits of information. So you'll be able to output 32 characters, or 16 characters per row, and there's 2 rows of information. This allows you to make your projects portable so they don't just have to be hooked up to a computer. You can program your Arduino, set it off somewhere, and it can display data without having a serial monitor available. Some other new concepts we're going to be talking about today are contrast. So pin 3 of your LCD is the contrast pin of your LCD, and it controls the brightness and the contrast of the LCD. Now it uses a simple voltage divider, which we've discussed in previous videos, and a potentiometer to control that contrast. So basically you can adjust the contrast. Now why do we need to adjust the contrast on these LCDs? Why aren't they just set by default? Well, it has to do with the special kind of crystal that's used. And this, so therefore the contrast of LCDs are highly dependent on factors such as temperature and the voltage used to power them. So again, if you're in a colder room, that's going to affect the contrast that you need to output on your LCD to see things. And I've had this in real life when I live in Alberta, Canada, so it's really cold here in the winter, and that's the time that I'm doing this course and making these videos, and I've actually taken the circuit in my computer and sat in a frigid cold car, which is like sometimes minus 20 outside, while I've waited for my kids to do jiu-jitsu. The reason I didn't go inside is there's no room for me to work in there. So I've tried to maximize the time I have, which is limited as a parent with 2 kids, and my wife is deployed. So I've actually, in real life, had to deal with this temperature thing. So it definitely is a factor in the contrast of the LCD screens. We're also going to talk about pixels, which besides being a movie starring Adam Sandler, it is also what make up the character space on these LCD screens. So, and the character space is the number of pixels in which a character can exist. So as you can see here, each character space is itself 6 pixels by 8 pixels. Okay, and so each character space is what makes up this 16 by 2 dimensions of the LCD. So again, there's 32 character spaces in an LCD, 16 in one row and 16 in the other. So, as usual, SparkFun provides a very good hookup guide onto how you should hook everything up. So the LCD, and the only thing you're hooking up in this particular circuit is an LCD and a potentiometer for the contrast pin, pin number 3. However, I have, for the coding challenges, added buttons and an RGB LED, so red, green, blue LED. So I have added some more complexity, but we'll get to that shortly. Here's the pins associated with the LCD. I'll kind of quickly go over them, but in very quick detail. For further details, go to the SparkFun Inventors Kit website. But essentially, you're going to want to have both external pins connected to ground, and then the pins, one in from each of the exterior pins connected to your power rail. So again, you can see here, pin 1 is ground, and pin 2 is VDD, or your 5 volts from your Arduino. And then pins 15 and 16 are your black light power, 5 volts, and your black light ground. So that's why, again, you'll do it like that. Then you've got pin number 3 is your contrast pin, which is going to be reading a value from 0 to 5 volts. And again, your contrast pin is connected to your wiper of your potentiometer. And again, the other 2 ends of the potentiometer connected to ground and power, respectively. And again, it doesn't matter which one is connected to ground or power as far as the external terminals of a potentiometer go. It just will affect, when you turn the potentiometer to the extreme left or the extreme right, it will just affect whether you're increasing or decreasing the voltage being read on the wiper. But for the most part, there's no effect. It's just, you'll just know one way. depending on how you hook, which terminal you hook up to power and which one you hook up to ground of the exterior terminals, it'll just affect which way the knob is full power versus zero power, i.e. 0 volts versus 5 volts. The wiper is always the middle pin. And then we have our other pins hooked up. So pin 4 is our register select pin. Pin 6 is your enable pin. I kind of skipped pin 5 for a minute. Pin 5 is your read-write pin, and it's just tied to ground. And the reason for that is because you can, if it's at 0, meaning ground, it'll be in write mode, and if it's a 1, meaning tied to 5 volts, or anything not ground, I guess, it would be in read mode. But an LCD is really for display. It never makes sense for it to be in write mode, or correction, read mode. So it will always be in write mode. We're always going to want to write to the LCD. So we don't give it a choice. We just tie it right to 0, right to ground, so it stays in write mode. And then we have 4 data pins that aren't used. So data lines D0, D1, D2, and D3 are not used. We don't need 8-bit data transfer in this. We only need 4 for most things, and that's how the libraries that we're going to use are set up. So we just have data lines D4 through D7 set up for 4-bit data transfer instead of 8. That's why these pins aren't hooked up. So that's that. Before I go any further, I'll show you. So this is the setup for, in general, for just doing circuit 4A. But for my circuit, because I'm doing the coding challenge, I've added, as you can see, I do have the original circuit, the LCD screen hooked up here. And again, all my connections, this green wire is connected to ground, the ground rail, and then the second one in is connected to power, the red wire here, so connected to my power rail. On the opposite side here, again, this pin, the far pin, is connected to this little green, which is connected to ground. It kind of toggles this way and then back this way to go to ground. And the second pin in is connected to power as well. And again, you can see I've got my contrast pin, which is my third pin in. Here is connected to the potentiometer. So this pin here, orange, the third pin in. And yeah, so there you go. Sorry, the blue. And these are my data pins. So I won't go over all that. It's kind of hard to see on the circuit. I've just used this connection here to hook into the breadboard. You may be able to see it, maybe not. I've got my 4 buttons which I'm using, and the wires with the corresponding colors for the blue, yellow, red, green. They're connected to my analog pins. So typically you hook up buttons into your digital pins, but because I've got a lot going on and I've got a lot of the digital pins taken up via the LCD as well as the RGB LED and some other button pins, I don't have a whole lot of real estate left as far as digital pins go on my Arduino board or my SparkFun Red board. So I've used my analog pins. I've discussed this in a previous video, that even though the analog pins are by default set up as inputs and set up to be used with analog reads, you can use them if you're in a pinch and you need them. You can use them as digital pins. You just have to declare them accordingly within your program and setup. So I've hijacked the analog pins for my button pins. I've also got the RGB LED, which is right here, which again, for those, if you remember, the RGB LED has a common ground, which is the second pin in here, the longest. Actually, I don't believe it is the longest now I think about it. Let me just see here. Yeah, so the longest pin there, the second one in from the right is the common ground. And let me just make sure I put this back correctly. Probably shouldn't have taken that out. Okay, and the other, this corresponds, the pin on the far right corresponds to red, hence the red wire, and then green and blue lights as well. And so all those connections are in here on pins 6, 5, and 3, it looks like. And then I've got this black button, which I'll discuss in the code, is connected to digital pin 2. And I'm using a pull-up resistor for that button as well. So one end of the button is connected to ground, and the other end goes through a pull-up resistor connected to the 5 volts rail on the breadboard. Each of the buttons, by the way, are using pull-up resistors, so one end of each button is connected to ground, the other end of each button is connected to the 5 volt power rail through a pull-up resistor, so that they're active low, meaning they're held high when they're not pushed, and they go low or to 0 volts when pushed. So I can upload images of my schematic here, of my circuit, if required, on the course forum. Just let me know if you interest them. If not, hopefully you can see most of the setup and connections here. I do got a lot of other stuff going on the board right now. That's for a further project. I've kind of got a good bunch of projects happening at once that I'm doing, but we'll just disregard that. Also, you'll notice I do have the TMP36 temperature sensor currently on here. It's just not hooked up right now. And that's, again, for circuit 4B, which we'll talk about in another video. But without further ado, let's get back to it. So the first thing we're going to talk about is the code. So again, the first circuit, before we get to the coding challenge, the code is going to be really simple. We're simply going to, it's going to be about adjusting the potentiometer. We'll change the contrast on the LCD screen. And really, which we've done really what's going to be happening is we're going to be doing Hello World. So we're going to be just displaying Hello World to the screen. So we'll do that first. So we're going to begin the program. We're simply going to import the LCD library. We're going to create an object or an instance of the liquid crystal library based on the pins associated with the register select, enable, and the data pins. We're going to begin communication with the LCD and set up the dimensions, which is a 16x2 LCD, a fairly common LCD that comes in a lot of the Arduino kits. And we're going to print out Hello World to the screen, and and the time as well. Some of the major things to note with the code, when I go through it here in a second, is that we'll need to include the liquid crystal library. So we'll do a pound include of the liquid crystal header file. And you'll notice it's in angle brackets. Again, any C++ built-in header files, so like header files that are associated with the programming language itself, and Arduino is based on C and C++, they're in angle brackets, whereas other header files that are kind of user-defined, not C++ built-in header files, or not programming language specific header files, are in double quotes. I think I've shown that before with in some of my tone projects where I use the piezo buzzer. There's often a header file that you include that someone's taken the time to already do up all the tones for, and that header file is included with double quotes. We're creating an instance of the liquid crystal library, which again just uses a constructor to take in 6 pins and sets up your liquid crystal object, your LCD screen, based on the pins it's hooked up to. We begin communication by calling the begin method. So just like we use serial.begin to begin communication via the serial monitor, we begin communication with the LCD by telling the program what the dimension of the LCD that we're using is. In this case, it's a 16x2, 16 columns, 2 rows. And the clear function just clears the LCD. The set cursor function just sets the cursor out of those 32 character spots that you could be. It decides where you're going to be. The first argument represents the column number, and the second argument represents the row. So this is the first column in the first row. So that's your upper left-hand corner. We've got an LCD print function. This is how you print to the LCD screen, kind of like print for serial monitor or print lin, and that's pretty much it. We'll talk about the coding and challenge in a minute, but let's first go to the actual circuit. So this is the basic circuit associated with the, let me just up the thing here, associated with the, like the actual, that comes with the SparkFun Inventor's kit guide. So this is not code I created. This is from the SparkFun Inventor's kit guide, which again you can find their circuit diagram and download the code at this website. But you can see it's really simple. It simply has the library. You include the liquid crystal library. You declare an instance of the liquid crystal library, so they named it LCD, and you pass in the 6 pins. Again, if you followed the videos before, you know I'm a big fan of constants, so I don't really like these magic numbers. However, in this particular case, it's not a big deal, especially with modern IDEs, like the Arduino IDE here, because you can just hover over, and I guess you can. There you go, hover over, and you can see what the pins represent anyway. So the first pin, where I'm passing an 8 in, is the register select pin, pin 9 is the enable, and pins 10 through 13 are D0 through D4, or correction D3. Those are your data pins. I highlighted out their one, or just commented out their one, because my pins are a little different, and I just instead of deleting it, I just commented out and changed the pin layout for my LCD. So that basically creates an instance of the Liquid Crystal library. And then in setup, all I'm doing is beginning communication with the Liquid Crystal library, telling it the program that it's a 16:2 LCD screen, clearing the LCD screen in case there was anything already on there. And then I'm going to, in the loop, I'm just constantly going to the upper left-hand corner of the LCD screen by going 0, 0, and I'm printing Hello World to the LCD. And then I'm going to the lower left-hand corner, so left justified button in the second row, and I'm printing the time. So I'm calling the millis function, which returns the current time since the Arduino's been last reset, and that returns time in milliseconds, and there's 1,000 milliseconds per second, so I divide it by 1,000 in order to print the number of seconds that have passed since the last reset. So that's the simple code. We're going to upload this. So I'm just going to plug in my Arduino, or breadboard, however you want to call it. So pin 11, got the right board selected, Uno, and I'm going to upload the code there. And as you can see, so the code uploaded, and you can see displaying on the LCD is Hello World on the top line, and on the second row we're just counting up every second. So it's just a count that will count up for a long time. So that's the simple code. That's all that does. It just does that. Again, if we restart it, it just starts back at 0. So nothing too exciting there, which is why we went to the coding challenge. So let's talk about the coding challenge. Oh, I bet. So the coding challenge. For this coding challenge, I wanted, as usual, I tried to incorporate all the coding challenges in one circuit. So the first coding challenge, it mentions that, hey, change the message and try displaying a different message to the screen besides Hello World. And then change the time. Instead of just showing like a countdown, show the hours, minutes, and seconds that have elapsed since the Arduino was last reset. So again, display hours, minutes, and seconds. And finally, count button presses. So we're going to add a count, the number of times that a certain button was pressed. And in my case, I've added 4 buttons, so I'm counting individually the different buttons that were pressed. So let's see what I did for that. So this is the code. Let's make sure that's the right text for you guys to see. Okay. So there's a lot of code here. I am going to go through it, but I'll try to speed it up a little bit. And then if you're really interested in going in more depth, just let me know and I'll post the code up on the course forum. And you can go through it in further detail. So, because if I go through it in excruciating detail, it will be a longer video than it's already going to be. I mean, we're already in 25 minutes. As you can see, it's I'm making this video, I believe, on December 22nd, and I originally did this code back on the 4th, but I've since then did a lot of the other projects. In fact, I've completed my final project associated with the SparkFun Inventors Kit, so I'm just coming back making the video now, so some of it will be a little rusty for me. But essentially what I've done is all this code is kind of not necessary for the coding challenge. I did have a lot of issues, especially with the serial monitor stuff. So I basically created some of my own debug code instead of using like a debugger because the Arduino IDE doesn't really have a good debugger. I don't find it wasn't working for me. Not for the Uno anyway. As you can see, debugging is not supported by the Uno, so I could take this code and post it into another IDE and just use it as C++ code, but instead I created my own debug code. Essentially, I have very quickly, I have a global debug flag that I can turn all the debugging on or off, a counter so I can display the count of my debug print lines so I know where they are. I've created a struct, which is basically, for anyone not too familiar with C++ code or C code, a struct is essentially a mini class, but whereas a class has state and behavior, so it has data and methods, a struct typically doesn't have behavior, doesn't have methods. And by default, everything's public in a struct, as opposed to in a class, everything is private by default, and you make the methods public. So you make your data private, and you need public getters and setters to access the data. Well, in a struct, everything's public by default, so you don't need getters and setters because you can just access the data directly. But again, I'm sidetracking. I've just created that. All this stuff is essentially just to help me with debugging. I've created a debug method where essentially I can call this method anywhere in the code, and I can pass it in an optional number of parameters to just print something out, whatever code the debug is currently at. I've added some indentation levels so that I can just indent the code appropriately depending on what level of function or loop I'm in. It's just for aesthetic purposes to help me kind of parse through the debug prints. I had an optional message I could add. I could optionally turn off certain debug statements once I didn't need them printed anymore. Again, this is per debug code as opposed to a global flag. I set an interval here. This just has to do with time functionality. Sometimes there's certain debug statements that would just print like a million statements in because they run every loop, and it just added a lot of noise to my debug printouts. So I've created basically a way to add a delay without actually delaying code, because as we know, delays stop the code from executing. So I'm using this as a kind of a time functionality to basically decide to only print out certain debug statements every 5 seconds or 10 seconds or so. IDs just to help me track the debugs. And again, these are all set up as default parameters, so if I include them, I overwrite the indentation level or the interval, but if I don't include them, they're set up to 0, empty string. They basically don't come into play. This code here, again, all has to do with whether or not I'm printing out the particular debug statement, and again, this just checks, hey, have I set the interval past 0? Like, do I want to print this stuff out every time, or do I want to wait? Check if the interval has passed for the specific debug message. Meaning, some debug message I don't want to print out. I only want to print out every 10 seconds or so to not clutter up my printouts. But again, I don't want to get stuck on the debug code. So if you are curious, just let me know in the comments, and I can post that to the forum. But that's some debug code I created. I've kind of split my code up a little differently than normal, just because there was a lot going on. So I've got my button variables in code here, RGB LED code that's specific, potentiometer code. So this is a little different. Normally you put all your constants together. It doesn't matter if they're for RGB LED or potentiometer or button. You'd have all your constants together, all your includes together if there's any libraries and that sort of thing. Whereas I've kind of separated things up. Just it made it easier to debug. So for the button stuff, again, I've got a constant for my black button. It's hooked up to pin 2. I've used the hashtag define, which is kind of the older way to do things, the C-style way, whereas for most things I've used the constant way. Typically, if this was a program that you were putting out for production or something, you'd be consistent. You would either choose to use all hashtag defines for your constants, or all const keywords in front of your variables. I mix them up on purpose simply because this is not for production and this is for educational purposes, and I want to just show that you can use this style or this style. As far as the program's concerned, they're both identical. This just means that I can use the keyword black button in place of pin 2 in my code, and I can use I can use num buttons in place of 4 in my code, and they're both constant values that don't change. I've got all my The next things associated with the button is these two lines of code, these 3 lines of code. This is all just my time functionality. It's just a better way to do debounce than just adding a simple delay in your code, which delays your code and doesn't allow it to keep reading sensor data and all this. This is just using time functionality. I've done this in previous programs, so just if you have any questions, post them on the forum or look in some of my other videos, and I explain using time functionality for debounce and the benefits over just simple delays. I've used a lot of arrays to store my things because I have 4 buttons. So my button states, instead of just I've got a button state array that stores the current button states, and these are active low buttons, meaning I'm using, as you seen when I showed you the circuit, I'm using pull-up resistors, physical resistors, pulling them all high to 5 volts, making them active low, meaning they go low when they're pressed. So the states are all high at the start. I've got new button states, meaning if the button state changes, I'm keeping track of the button counts for each button. And the button pins, I'm using an array. So I'm using an array for all of my button stuff because I have 4 buttons, and array is just more efficient. Then I've got my RGB LED code, so my red, green, blue LED code. I've again just declared constants for my button pins. I've got a constant for my potentiometer pin on A4, analog read. I've got all my stuff for my liquid crystal. So again, you could, if you wanted your code to be a lot simpler or a lot less verbose with less lines of code, you could get rid of like all of this here. These are all just constants. These are constants associated with all of the pins. My register select pin, my enable pin, and my 4 data pins. So when I initialize an LCD object with the specific pins, I can put in constants so I know what's going on. But really at the end of the day, I could have just done this like in the previous code where I just used 8, 9, 10, 11, 12, 13, the way they did in the SparkFun Inventors Guide, and eliminated all of these constants. So it's up to you what you want to do. I like constants, I don't like magic numbers, which is why I've also got 2 constants for the display width, which comes into play later in my code, and my scroll speed time, 300. I had some more debugging code here, and then I've got some time functionality code. You'll notice that I separate all my headers for my code just to keep track with different symbols. So I've got like the caret symbol for my LCD code, the percentage sign for my potentiometer. I did that because potentiometer is like a variable resistor, a certain percentage of resistance. RGB code, button code. But for the clock, my time functionality code, I separated with these parenthesis and the less than sign symbol that look like a clock pointing to like 120 or 125. So just thought that was kind of fun. My time functionality and Boolean flags, again, this is just used for instead of using delays in code, I wanted to create non-blocking code, so I'm using a lot of time functionality. Boolean flags allow me to track if I want to output a message or not, because if I come into a display for the first time, I want to display a welcome message or something per se, and I don't want to do that if I just stay in the loop in that same menu. So this just allows me, the Boolean flags and the time functionality are just for really aesthetic purposes and things like that. I've got a lot of function prototypes. Anyone familiar with C++ code know that if you create your functions, if you use your functions in code, like in your setup or loop, before you've declared them, it won't work. The compiler doesn't know where they were. So you need to declare and define your functions before your code. But then that means you've got all your functions before setup and loop, which is, it's not, I don't like it. I just don't think it looks nice. So instead, I like to have my setup and loop as my first functions. But if in order to do that and have all your functions defined after they're going to be used in setup and loop, you need to use function prototypes. Basically, the compiler can look at this and be like, okay, I'm going to expect that this function is defined somewhere in your code. So if I see it in setup and loop, I'm not going to freak out. I'm going to allow you to do it because I know it exists somewhere else. And again, you just need to make sure that your function prototypes match the same signature when you define your function. So, the same return type and the same signature with the same parameters. You technically don't need to include the parameter names. Like I could get rid of this parameter name and that would still work. But I like to have them in there just so they match exactly. And the parameter names are descriptive. They let me know, like when I'm looking at my set color function, they let me know that these 3 int parameters are associated with the red, green, and blue colors. Whereas if otherwise, if I just had int, comma, int, comma, int, it wouldn't be as descriptive. So those are all my function prototypes. I like to modulate my code. I like to make it very modular in the sense that when I read my loop, for example, it reads very simply, kind of like pseudocode, and it's not bogged down with code. In setup, I'm setting up communication with my serial monitor, 9600 baud rate. I'm setting up communication with my LCD using the begin function, and then clearing anything that's on the LCD. I'm using this for loop just to iterate through my button pins and set each of my button pins using the pin mode function, and I set them up as input. And yeah, and I again, this code doesn't save a whole lot with just 4 buttons, but if I had like 10 buttons or 50 buttons, or the more buttons you add, you're not going to change this code. You're simply going to change the number that you're right here. So as long as I is less than 4. And I did all this talking about how I don't like magic numbers, and I've included 4 here, which I just told you that there's 4 buttons, so we know what that means. But I really should have probably used, if I go up to my constants for button pins, I made a constant for num buttons. So, which equals 4. So I can use num buttons in place of 4. So I made a nice constant and didn't use it. So shame on me. I'm going to update that right now. But so yeah, in my code, all I have to do is update num buttons in the future if I add more buttons, and update num buttons here, and I can include a lot more code very easily. So that's one of the advantages of using arrays and for loops to iterate through them. I've set up my pin mode for my black button as an input pull-up. So the reason I did that is because these ones I just set up as input because I used physical resistors as pull-up resistors. And in this one, I don't think I had a resistor at the start, an extra resistor. So I just used the internal resistor associated with the the Redboard microcontroller, which has like a 20K resistor by default. So if you use input pull-up, you get to use that. I'm calling the set color button. I'm passing in -1, which is kind of a value that will allow the color, the RGB LED to be set off at the start. I don't want it lit up, so that's why I use that. I use my pin mode to set up my 3 pins, LED pins associated with the RGB LED. So my red pin, green pin, and blue pin, and then I'm outputting to the LCD "Hello World" code challenge, and then delay for 4 seconds. So this is all just your LCD code. And then I call the show menu function. That's a function associated with the serial monitor that it's going to allow me to toggle between the different display options, different menus options, which allow me to display different things on the LCD. As you can see here, I had at one point an analog write to the blue pin, 75. This was just something that I had done when I was working in a cold car and my LCD wasn't working very well. I could barely see the characters because it was freezing the car. And again, liquid crystals display, the contrast is affected by temperature. So if you're working in a cold car with no pot screwdriver, I didn't have a potentiometer screwdriver with me to adjust the potentiometer, adjust the pot. And in case you're wondering, I'm using a different pot that came with the kit. So I'm using this type of potentiometer here. Still works the same as any other potentiometer, still 10K potentiometer, but it has this little, you need a screwdriver to access it. You can't turn it with your thumb. So I had to quickly just use an analog write to, sorry, let me just get back to normal here. I had to use an analog write and just, through software, change the contrast pin as opposed to potentiometer. That's why that's there. In the loop I don't have much code because I'm compartmentalizing so much of my code and using modular programming style, and made a lot of functions, and my functions access functions. So I've got a lot of helper and utility functions as well. So really my code, I like my code just to read like pseudocode and just kind of explain what's happening. Right now I'm just doing time now. I'm using the millisecond function to determine the current time, and that's going to come into play because I'm using a lot of time functionality instead of blocking code and delays and stuff. I probably should put a little more comments here. I typically like to use a lot of comments to explain what's happening, including Doxygen style comments, which I've talked about in previous videos. But these are all inline comments, not Doxygen comments, but this is like a Doxygen comment here. But sometimes when I'm doing iterations, I have encoded certain things or I haven't explained things. Again, that's more or less just because the code is still a work in progress, but I wanted to get the video out there. So, but typically, yeah, comment as much as possible. It might be good to leave a comment here and just explain what's happening here and say something like, used for time functionality, functionality, and non-blocking code. I mean, that's not really a good comment, but because that still isn't. That's kind of our, ambiguous what that means. But it is good to throw comments in here, unless it's really common like this. Count button presses. Not really necessary to put a comment here. It's pretty obvious what that's doing. But anyway, that's what I'm going to do. I'm getting the time, and then I'm handling serial input. So I'm going to check for the serial input and update the menu option, because again, a large part of the coding challenge is I made it so that there was a menu via the serial monitor, and the user could type things in via the keyboard and affect what displays on the LCD screen. And then I'm going to count button presses, and then finally I'm going to handle the menu selection, which takes in the current menu selection, which would have been determined by the handle serial input, and this is a global variable, and I'm going to handle the menu selection. So I'm going to do different things based different operations, display different things to the LCD depending on what the current option is. Again, this would be a great candidate for a comment to explain that. And then I've broken down my functions. I've got to start getting a little quicker. This video is getting quite long, but I've got a lot of functions associated with the serial monitor themselves, so dealing with the input and output to the serial monitor. And basically my show menu function just basically shows what the menu options are. Press 1 if you want to change the LCD message, 2 if you want to show the time since reset, 3 if you want to count button presses, and 4 if you want to show the potentiometer value. I've got the handle, I've got the handle serial input option, handle serial input function here. And basically what it does is it checks to see if there's anything available via the serial monitor. And if there is, I use serial.read and assign that what I read in to this char variable choice. And then I'm ultimately minusing the character 0, which is the decimal number 48, from choice, and assigning that to current menu option. Current menu option is an integer variable, so I'm assigning the current integer associated with the menu option, and then I'm printing that out. So if you look at the Doxygen comment I have here, it basically, the reason I'm doing that reading via serial, or I'm serial.read, and then doing this whole minus ASCII thing, if you want to pause the video and read into it on your own, it's basically because I'm reading in a character value for if they type in a 1, 2, 3, 4. Serial.read returns the character 1, 2, 3, or 4, which is a decimal number different than what you'd expect. Like 1 is 49 in ASCII, like the decimal number 49. So I need to subtract from it 0, the character 0, which is decimal 48, and that way I can actually convert, when I'm reading in character values, I can convert them to an integer, which is what I'm using in a switch statement later. So this is probably more complicated than it needed to be, which is why I do suggest pause the video, read through the comments, and you'll understand why I'm doing that. Alternatively, I could have just used serial.parseInt, which would have been directly convert the input to an integer. I chose not to do that simply for the fact that I like doing the different things. This is a learning environment. I'm learning coding. I'm learning how to work with the Arduino. So I did this purposely more convoluted just because, I've seen this in some tutorials, my Google searching and stuff. And I wanted to do it this way because I actually do use parseInt later on in the code. So the reason for using this over parseInt is just to try different things. But parseInt would have definitely been more direct. Handle the menu selection. Basically this just, if the menu selection has changed since last time, I clear the LCD screen and I update some options. This is just, I don't want things to happen if I'm staying in the same menu all the time. I only want to do certain things if I've switched menus. I use this switch statement to decide what menu option I've currently selected as the user. If it's menu 1, we're going to change the message. We're going to output a different message to the screen, allowing the user to type in the message. If they selected 2, again, I display the time. 3, I update LCD button count. 4, I show pod value. And 5, I just default back to show the menu again. In all cases, you'll notice I have a function going on, turn off RGB LED. That's because I only want the RGB LED working when I'm counting the button presses. So that's a switch statement. Again, I've talked about the switch statement in previous videos. It accepts sort of an integral type value as its selection option here, and then the cases. This will be associated with the different cases that get chosen, and make sure you don't forget your break statements. And it's good practice to have a default case to happen if one of the options wasn't chosen. This function just clears my serial buffer, just to eliminate things that I might not have read in. Wait for user info. This just basically, while the user hasn't typed in anything, while I'm waiting for them to type something in, I just stick in a forever loop, a while true loop, waiting for them to type something in. And you can see here that I actually do use the serial.parseInt, and it's a lot cleaner line of code. It's just a single line of code. There's no confusion. Why am I subtracting 0? But again, I want to try different things. That's all the serial monitor functions. I understand I'm kind of going really fast and not into detail, but that's because this video is already long. So again, if you have questions, post them to the forum. I'll be happy to answer them. The LCD functionality, I've got show LCD menu. This was something I was doing in addition to showing a menu on the serial monitor. I had a function that I created to show the LCD menu as well. I'm not sure if I commented that out though, because I didn't know if I liked it. So I can't remember actually. But I did at one point. I was displaying a sort of an abridged version of the menu on the LCD monitor. Obviously I couldn't print the whole thing with full sentences and everything because I've only got 32 characters to work with. This is display the last menu selected, which again, depending on what was selected, that's what my coding is. So if the last menu selected was the first element of the array associated with the menu items, well, I'm displaying the change message on the LCD. Otherwise, I'm displaying display time, update LCD with button counts, or show pod value. Else, no matter what, turn off the RGB LED. This function here is associated with if I chose option 1 and I'm printing a custom message to the LCD screen. If the user types in a message that's longer than 32 characters, which is all that the LCD screen allows, I no longer display a static message. I display a scrolling text message. So that basically comes onto the screen from the right and goes off the screen from the left and just scrolls. And so this functionality takes care of that. If you go into your Arduino IDE and go to examples and then go to the liquid crystal library that you would have downloaded in order to use the liquid crystal, there is a scroll display examples. So just that's one of the spots I found out the scroll display. I also Googled and went on Stack Overflow and stuff and in the forums, but there's also some good examples here as well. But that's what that code does. Again, basically, if the message length that someone typed in is greater than the LCD display width, which is a constant I created representing 16, then I do some different things. I pad the message. Basically, me padding the message is just adding blank spaces, so that way I don't always have to use LCD clear. Using LCD clear sometimes causes flickering and is not fully recommended. Sometimes it's better just to overwrite your messages with extra spaces. That's kind of what that does. I've got some functionality for my color, my RGB. Got the RGB LED functions. Correction, let me just save that. Basically, set button color. When the user presses a button, I want the color that displays on the RGB LED to reflect the button they press. So again, if they press the blue button, I want the color to be blue, the RGB LED. If they press the yellow button, I want yellow. That's why red and green are full values, 255, and blue is 0. Again, the values for each of these parameters can be 0 to 255. A red button is red, green button is green, and if they don't press any button, so meaning they haven't pressed a button, well then I don't want the RGB LED to be lit at all. I want it to be turned off. Set color, just, this function, set button color, is calling the set color function, which is this function here that just takes in the 3 int values representing the intensity for red, green, and blue. Turn off RGB LED, I simply call my set button color function up here, but I pass a -1, which will cause the default to execute, turning off the RGB LED. Again, a lot of this stuff I could just call the set button color function, passing in a -1 everywhere I'm using the turn off RGB LED. Like I'm using it a lot up here in the switch statement. I could just have called the set color function and passed in -1, but it wouldn't be as explicit, whereas I like just reading this and it's quite clear what this is doing. I don't need to put a comment here. I can just realize, oh, this is turning off the RGB LED. So I like breaking up my code into all these different functions. It does make for some more code, but I feel it's easier to maintain. The button functions, I've got a function here to count the button presses. Again, I just iterate through my array of buttons and I basically check each time, hey, is the button pressed for that particular button? And this is button pressed is a function I've created. If it is pressed, I increase the button count for that particular button, and I set the button color based on the button that was pressed, and I update the LCD with the button counts. So again, this one function uses 1, 2, 3, 4 other functions. Again, I'm relying on a lot of modular code, so that way I can build my code up from the ground up, and it's just easier to maintain and everything. So is my button pressed function. I'm using time functionality in here for my button debounce. Basically, hey, is the button state changed since the last time? Meaning, is it pressed and it wasn't pressed before? And has enough debounce time passed by using time functionality, not a simple delay? If that's the case, then I'm just going to return true. I put kind of return true. I could have just put return true here because this won't be this. This will always be true if I get in here. I'm just again trying to do things different ways. And I'm updating the LCD button screen. Again, I have, when this option is chosen, when the user is on this screen on the LCD, it shows green, blue, red, yellow, a count of what's been pressed, and I'm just updating, I'm just outputting, the name of the color of that particular button and its count based on the LCD. Let's try to get a little quicker going here. Menu helper functions, change message. Again, I'm just allowing the user to type in a custom message. When they're on that screen, the only way to get off that screen, basically, if they type something in, normally I'm switching screens based on the user typing things into the serial monitor, but when they're on the custom message screen, everything they type is a message that I'm assuming they want to display to the screen. So the only way to escape that screen is by pressing the black button. So if the black button is pressed, I'm always checking, hey, while serial.available equals 0, I'm checking that if the black button is pressed, oh, I'm going to change the current menu option to 0, meaning I'm going to escape the custom message menu. So pressing the black button gets me out of the custom message thing. I've got just a lot of code in here that just is associated with me getting user input from the user, and this code here is really if they type in a message that's greater than 32. Again, I create a scrolling message. Otherwise, I'm displaying the message statically on the LCD screen. I've got time functionality here. This is just used to determine how fast I display the message, the scrolling message. So that's a constant I've created up above, which I have at 5 seconds. So how much time I have to display the scrolling message. Display time. If I'm displaying the time, I go into this function, I turn off the RGB LED, and I display the time in hours, seconds, and minutes just by dividing appropriately. Like, there's 60 seconds in a minute, 60 minutes in an hour, that sort of thing. I pad hours, minutes, and seconds with 0. So this code, a lot of this code is just associated with padding my timing so that my my timing, the output is always in the hours, minutes, seconds format. I don't want like a single minute. If the minutes are only 7, I don't want just a single M there. I want it to be like 07. And if the hours are only 4 hours have passed, I want it to be 04. So all this function, this padding of zeros, is just to accomplish that. And show pot value. This is the final function here. And basically I turn off the RGB LED as I always do. And I'm just doing an analog read off a pot pin, which is analog pin 4. And I assign that to pot value, and I basically just print out the pot value. So that's a lot of code. I know that was a long video going through that code, and it still wasn't very detailed. I had to like kind of just, pay lip service to a lot of the explanation because it would just be that much longer. So if anyone does have any questions, post them to the forum. I'll be happy to provide the code or answer any questions specifically. So let's upload this code first of all. So right now, before I upload this, right now we're still displaying, I have the original code on there, just the original 4A circuit associated with SparkFun Inventor's Kit Guide, which displays hello world and the number of seconds that have passed since the program started. So in this case, 2,000 and some seconds. So a little bit of time. So now what we're going to do is we're going to upload the new code, the coding challenge code, and see the difference. And again, I need the serial monitor available because I'll just keep the serial monitor like this, because the serial monitor is important for this. Okay. So you can see hello world here. And there's nothing displaying all of a sudden, and that's the code. So originally I did have a different display, and I'm like, I don't need that. So what's important is over here on the serial monitor. Choose your coding challenge adventure. Again, if I press 1, I'm going to change the LCD message. 2, show the time since reset. 3, count button presses. 4, potentiometer value. So if I press 1 and press enter, if you'll notice when I press enter, look down here and you'll see something that says enter a message. So you can see enter message, and I also have it here on the screen because option selected is 1. I'm just going to change something very quick. So I'm just going to, right in the camera's way, I'm going to just update the contrast so that the message, because the messages aren't showing up very good. I'm just going to reset this quickly and update so there, that's much better. I was having trouble seeing the words, and I'm sure it showed that way on the video as well. So I just re-uploaded the code so you can see the message shows up again. I'm going to press 1 and enter a message. So now I'm going to enter a custom message. So if I put hello comp 444 like that and press enter, it shows on the LCD, and I'm still in the enter message phase. So I can't exit the enter message phase without pressing the black button. So in the meantime, I can just keep typing things. So I could put, how's the weather outside, question mark, and type enter. How's the weather outside, question mark. And you can see I didn't put in any coding to verify the words and block this. That's something you could easily do. In fact, if you like this coding challenge, I would encourage you to do that. It wouldn't be that difficult. You just basically would have to separate things into Word, basically figure out when you had spaces, and then whenever you had spaces, kind of that would determine, oh, okay, well, if I'm not in a space, do I have enough room to output the thing until the next space, which is a word? And if you don't, then you'd go on the next screen. I didn't do that. Again, the coding challenge was already getting fairly long, but that's an easy fix that you could do. But anyway, that message still landed on one, it still landed within the 32 character space, so we didn't have to do any scrolling. But let's do a long message. This is probably going to be a longer message. So this should be more than 32 characters, and for some reason I went uppercase. I got angry there at the end. So this should cause a scrolling message when I type that. So this is probably going to be a longer message. And so you can see it's coming in from the right side of the screen and then just scrolls off the left. So, but I'm going to show you if I try to like select one of the other options to get out of this menu. Let's see, I try to select 2 so I can go show the time. Nothing. It thinks I'm just typing a custom message. So any of the numbers that I try to click to get out don't work. In order to get out, I'll just go hello there. In order to get out, I actually have to press the black button. So if I press the black button, now I'm out of the custom message selection. So it still shows the previous message I typed. I just allowed that to persist. I could have easily made it when I pressed the black button, the screen cleared and re-showed the menu. And I think I did have that in a version. I kind of mentioned in the code that I think I commented it out because I just, for whatever reason. But right now I'm not in that screen anymore. So again, you might just want to make that more explicit, and I could have made it when I pressed the button that I cleared the screen and then said, reprinted the message. But I didn't. But you can tell I'm in a different screen because right now when I press 2, I'm not printing 2 to the screen. I'm entering 2. I'm entering the show time reset menu, which just shows the time since this the Arduino was reset, and apparently it's been 3 minutes. And we can prove that by resetting it again. I'm going to come out of this, go back to my challenge, but I'll go into the reset right away and you'll see that it's a different time. So in this case, I'm going to go to 2 right from the start instead of going into this selected menu because we've already done that. And you can see that the time is based on the actual reset of the Arduino. Now if I press 3, and again, in case you're not watching, I'm pressing 3 up here. You can see I selected 2, that gave me the time, and then 3, right? If I press 3, now I'm in the button press mode. So, and you can see if I press the green button, I increase the green button count, and you can see the RGB LED. I'm not sure if you can actually see that on the camera, but it's green right now. If I press red, I've increased the red count. If I press, and the red, the RGB LED is red. It doesn't really look like red in the camera. It looks very red in the real world here, but if I press yellow, the yellow increases. Again, doesn't really look yellow in the camera. I'm not sure what's going on, but I can assure you in real life these are the correct color. If I press blue, the count increases. So you can see I've increased each count, and as I press the button, the count increases on the LCD display, as well as the color changes accordingly. So again, if I keep pressing like green, I can keep increasing the count. The color didn't change, it stays green because I kept it on green, but I could press red. I could switch back between all the colors, right? And just increase the count however I want. So, and that's all using time functionality button, time functionality button debounce. So that's that. If I want to go to another screen, I would click on 4, so option 4, and option 4 shows me my potentiometer value, I believe. Wait. Oh, I've timed out here, I think. Oh, actually, I think I have it. Oh, technical difficulties. Let me just update that. I did make a slight adjustment right before I started this video, and I think I might have messed something up. So I might have to quickly go back to the code and change that and come back to the video.